Okay, on this example, we're given our original function f of x is already graphed, and we are asked to graph the derivatives function, its graph looks like on this exact same axis. So we kind of have two different sides of this, right? We have this side that's all curved, increasing the whole way, and then this side that's decreasing, but it's a nice straight line. It shouldn't be too bad to get to, but as we look at this, I'm going to kind of treat it as two separate problems. I have the left-hand side. Looks like it tops out, and this is the very, very top that would have a nice horizontal line going across here. You kind of have to use your imagination because it sort of comes to a point here, but I think we have to say that that's going to be a horizontal line for its tangent line. So that's going to indicate a slope of 0 for that horizontal line. So that's going to be a point right here at the origin. All right, next we want to find one additional point, at least for this side. I think if we kind of go here to -1, if I tried to, I'm just drawing in the tangent lines for right now, so it's going to hit the graph right here. Let's make that a counting problem and go count 1 up and to the right 1. It looks like we get to another point that's on that same line. Or you could go down 1 and to the left 1, get to another point on that same line. So that's going to be a +1 for the slope of this blue line, the tangent line going across here. So at -1, we're going to get a 1 for the slope of that tangent line. So that's a second point for the derivative going on here. Now we could do the same thing. Maybe we move over to -2 and try to draw on its tangent line. Let me clear these out. I think if I draw it in, we can visually kind of see here at -2, that looks like the tangent line at -2. And that if we counted up the slope, go rise over run, go up 2 and to the right 1, that's going to be +2 for the slope of this tangent line that I've drawn. So at -2, it's going to have this point on the derivative. So it looks like we have this nice line cutting right through the second quadrant. Slope of -1, I guess, on that line. All right. The second half of this is we have this straight line segment on this function f of x. So the tangent line is going to be the exact same as the slope of this line segment. So it looks to me like we can go down 1 and to the right 1, thinking rise over run, which would be -1 coming across here and it's going to be a constant because this has a constant slope. All right, let's put that all together, get a nice graph. We said on the right-hand side, it was a constant at -1. We had a 0 right here, right? A horizontal tangent line, that was a maximum. And then right here, we had +1, +2 for the slopes. Now notice on this, I didn't extend this out. If you accidentally don't extend it out, we're supposed to do the entire interval from -4 to +4. You can come back to your graph and just pull it out to the edge, hit submit, get full credit, move on to that next one. All right, good luck on it.